I'm Dan the author, and those who have been with me up to now know this. What you don't know is my nickname is Dorf. I also have a website, dorfonconcrete.com. My degree is architecture, and my background for now over 30 years is in the concrete construction industry. So, in Unit 10, we will be discussing foundation plans. You will learn to identify footings on a foundation plan. You will describe the different types of foundation support systems and also be able to identify the components of the foundations. The building structure consists of two major components: the foundation, which supports the structure, and the above-grade framing structural system that we will cover in Unit 11. The various types of foundation systems are footings and wall, grade beams, auger cast piles, caissons, steel piles, and mat foundations. The footing size and location are shown on the foundation plan. Footings are the feet upon which the entire building rests, and the footings must rest on undisturbed soil. Footing sizes are determined by the weight of the dead load, which is the weight of the building materials, and the live load, which are the loads from the people and the equipment occupying the building, and of course the load carrying capacity of the soil. And the footings are almost always reinforced with rebar. Here is an example of a simple partial foundation plan. You will have a footer and a wall as shown in this section and wall elevation. Here is a residential foundation plan with the basement. Note how the foundation is also shown on the building architectural elevation using dashed lines as if hidden by the earth. Here is a foundation plan of an office warehouse building. This is a relatively simple and typical slab-on-grade foundation for a commercial building, consisting of wall and column footers with short concrete walls. There are some larger retaining walls located in the loading dock area, which we will discuss later. Included with this foundation plan are the general requirements for the 6-inch slab-on-grade, and at the lower portion of the plan are additional general notes and reference marks. Also note all the section cuts that are referenced to other sheets. Here is an example of a section cut for a footing and wall and a dock leveler. Now let's talk about retaining walls. Retaining walls are rigid structures used for supporting earth mass laterally so that the earth can be retained at different levels on two sides, as seen here with the lower earth side and the higher earth side loads. The earth's pressure on the higher side is wanting to push the wall over. The concrete wall is designed to resist that force by having a larger width of the footing itself extend under the earth, so that the earth's weight acts like a giant anchor holding the footing and wall in place. Here is an example of a column footing and section. A column footing is usually a square or sometimes rectangular chunk of concrete poured in a hole on grade sized to support the dead and live loads from above. Column footings are typically located at the intersection of building center or column lines, as seen here. The footing will either be provided with the size of the footing along with the required reinforcing steel or a footing identification number reference to a footing schedule. The engineer here shows typical interior column footing detail. This would be used to reference all column footings similar in size. On this partial foundation plan, there is a combination of caissons, also called concrete drilled piers for interior column footings, and wall footing with a concrete wall. The drilled pier's diameter is defined with top and bottom elevation requirements. The wall foundation and wall is detailed in this section cut. Here is the drilled pier caisson schedule, referenced to the foundation plan, and grade beam schedule. Grade beams are structural beams constructed on grade, its namesake. On the foundation plan, they are referenced in the grade beam schedule. Here are two examples of grade beam details. Auger cast piles. Auger cast piles are drilled with steel augers 12 to 18 inches in diameter. While the drilling shaft is being removed, concrete is pumped into the cavity. The piles are capped with a concrete pile cap to create the final load carrying capacity. Typical types of piles are friction piles, held by the earth, or piles drilled and socketed into rock. Using the gateway tower drawings, here is an example of a foundation utilizing auger cast piling building support system. Note the pile caps with individual piles underneath. And here is an example of pile and cap section detail views. Caissons. Caissons are also called drilled piers. They are like auger cast piles except larger in size and don't go as deep, typically 18 to 72 inches in diameter. They are drilled to an engineered depth. When the drilling is complete, the bottom is tested for soil load carrying capacity, and then a steel cage is installed. Next, the cavity is filled with concrete. And sometimes a cap is installed over several caissons to increase the load carrying capacity. Also note typical column and drilled pier notes. Steel piles. Steel piles can have various shapes, but typically are H-piling. There are heavy structural steel shapes that are hammer driven into the ground to a point of friction resistance or suitable support stratum. The piles are capped to create the final load carrying system. Slab on grade, abbreviated SOG. A slab on grade is a concrete floor poured on a prepared subbase material, reinforced with mesh or rebar, sometimes with steel fibers or other synthetic materials, and occasionally with nothing. The reinforcing is used to help resist cracks and crack propagation. Remember, concrete is strong in compression, but not in tension. Most slabs on grade are considered non-structural. Here is an example of a monolithic slab with turned down footings and a floating slab between two concrete walls. Here is an example of a section of an interior and exterior slab on grade. Note the substantial subbase, the mesh reinforcement, and the insulation barrier. Also note on the exterior slab the half-inch expansion joint material isolating the slab from the building structure, or as shown in this picture of a structural floating slab on grade with many beams running through the slab for additional support. This would be a typical residential foundation slab in Texas due to the expansive soil condition. Waterproofing. Concrete resists moisture flow through it, but is not waterproof. Waterproofing of foundation walls is needed in areas where soil and climatic conditions demand protection from underground water migration. Residential waterproofing can be done with a variety of materials, but usually consist of mopping the outside of the foundation wall with tar and asphalt. And on commercial buildings, they are typically engineered. A layer of crushed stone is laid along the foundation wall and below the floor to allow water to drain away. Being green as it relates to storage. Damage and lost materials create unnecessary waste on a project. Store materials in a secure location to minimize theft. Protect stored materials from damaging weather. Locate materials away from Worker pathways to reduce the chance of accidental damage. Keep materials neatly organized to ensure that the materials can be located when they are needed. Concrete construction offers many employment opportunities. Concrete laborers who place the concrete, carpenters doing formwork, concrete rebar ironworkers setting reinforcing steel in concrete forms, and finishers who work on the slabs, to name a few. Time to test your knowledge. Pause the video here and review the material in Unit 10. Then answer the questions on pages 181 and 182. When complete, continue the video to see the answers. Repause the video and check your answers. Pause the video here and answer the questions in Activity 10-1 on page 183 using the Sullivan Residential Building Plans. When complete, continue the video to see the answers. Repause the video and check your answers. Pause the video here and answer the questions in Activity 10-2 on pages 184 and 185 using the Marcelli Residential Building Plans. When complete, continue the video to see the answers. Repause the video and check your answers. Pause the video here and answer the questions in Activity 10-3 on pages 186 and 187 using the Delhi Garden Center plans. When complete, continue the video to see the answers. Repause the video and check your answers. This completes Unit 10.